But the reality is that you will use them absolutely all the time. I would say I don't know, probably 70% of the code that I write is dealing with something that is in an array or accessing something on an object. It is so common that really getting to grips with these concepts of collections of data, it's going to be really important for you. And in a few weeks, when we look at some other ways to manipulate data in arrays, that is going to become even more sort of powerful and useful. And it really is the sort of bread and butter of writing JavaScript. You deal with collections of data so frequently. So arrays and objects are both technically collections, and at this point I should say that if you've done any sort of reading around on MDN, Mozilla Developer Network, or anywhere else, you might have come across some other types. So there's now a set, which is actually its own type, which is sort of like a unique collection. But that's a pretty new feature in JavaScript, so we're not really going to cover that. And also, arrays and objects, they're pretty fundamental to most programming languages. So although JavaScript has a few other sort of sets and maps and other things that we could use and could include in this collection of collections, they're a bit JavaScript specific, and we want to talk about slightly more generic, language agnostic things. So arrays and objects, we're going to stick with those. They're collections because they store multiple pieces of data. Oh, sorry. Oh no, sometimes I do these and I just yawn all the way through. I yawn less when I'm coding, so bear with me while I'm yawning through the slides. So collections store multiple pieces of data, and is that someone joining? Do I have to? Oh no, someone just said something. I'll come back to that later. The data that we looked at, the types of data that we looked at a couple of weeks ago, strings, numbers, booleans, undefined, all of those, they are individual pieces of data, and our collections store multiple pieces of data. They also can store other collections. So an array can be an array of arrays. An object can have nested objects. That's how we refer to an object inside an object. But we'll look at that a bit later on. First, arrays. An array is basically a list. It's just a bunch of things in an order. So you always have one item that is first, then the next item is always after that first item. You can kind of change the order if you want, but unless you change the order, it is a fixed order. The order is defined by how the items in this list have been added. So you might say to someone, okay, let's add this to the top of the list because it's the highest priority, or this one's lowest priority, so let's add it to the bottom of the list. It's exactly like that. So we access those values, those items in the list, using indexes. So when we say let's add something to the top of the list, that is index 0. That is the first number. See, I told you like 4 times already. That's the first number that computers use. Therefore, whenever we count, we're always counting from 0. So the first element in the array has the index of 0. Arrays can store any type of data. I said that before. And arrays use square brackets. I mean, objects also use square brackets. Other things also use square brackets. But generally, if you see square brackets, you think, that's an array, or I'm accessing some element on an array. Sorry, it's really bad. I blame it on not being able to see anyone. And that's not me saying you should turn your videos on, because of the way this all works, I can't see your faces, I can't see the videos anyway. But it's just like I'm talking to a screen and there's no human feedback. So my brain is just like, what are you doing? I want you to go to sleep now. Have people noticed that you're kind of more tired after doing video calls since lockdown? More tired compared to a day in the office, because you're like, your brain is just confused. Anyway, that's what I'm blaming it on. It might just be incredibly boring. So, to create an array, we have our variable type. Here we've got a constant variable. We have the name of the variable, which is names, and then we set that variable to a value of something that is contained in square brackets. So there are those square brackets. Haha, that's an array. And it's just a list. If you're used to writing in English, or in most certainly European languages, when you write a list in a sentence, at least, you have words or phrases separated by commas. Oh dearie me. I need to have like 2 coffees before I do these. It's so bad.
We're just expecting that you're going to do it, so don't worry.
You're just expecting. I know, but honestly, I'm really self-conscious about it. It's really weird, and I don't. It's this situation that makes me. It's so bizarre.
You might need to do a few jumping jacks or something.
I know. As I'm doing it, I should get a standing desk maybe. That might help. Probably won't construct one right now. Although I'm looking at something that I could put on the table. No, I won't. Okay.
That's what I'm using now.
Does it help? Do you find I've never used the standing desk?
It definitely helps. Yeah.
Okay. Yeah. Maybe I'll do that next time. So we're creating this array. Got the square brackets. The square brackets mean it's an array. It's just a list, so they're comma separated values. In here we do have words, but could be numbers, could be booleans, could be undefined objects, arrays, could be anything. We can access the length of the array. The length is 2. Now, quite often I kind of get people saying, why isn't that 1? Because I thought arrays were 0 indexed. I thought arrays start at 0. Yeah, when we use the indexes, they do start at 0, but the length of the array, if the length of the array is 0, that means there's nothing in the array. So whereas indexes, you have to kind of think, okay, I want the first one, therefore I have to -1, therefore I use 0. Whereas length, you don't have to kind of pass that in your head. You can just say how many elements are in the array, and that is the length. If we want to access a particular element in the array, we use square brackets. Again, we say the name of the variable, the name of the array, and then we use our square brackets with an index inside the square brackets. And I'll talk about what exactly that is a bit later on when we look at objects, or after we've looked at objects. But we use square brackets, we pass it an index, and that gives us the value at index 0. On this line, we're trying to get the value at index 10. So in sort of English, in the 11th position in the array. But this array only has 2 elements in it. It doesn't throw an error. It allows us to do this, but it just says that there is nothing stored at the index 10 on this array collection. So anything where the index exists, it gives us the value. Where there isn't something stored at that index, it gives us undefined. It may sort of be obvious, but you might also think that other languages maybe would throw an error and wouldn't allow you to do that. But in JavaScript, it just says, no, there's nothing there, but it kind of handles it. Okay, we've got the same names array. We have names length is 2. Now we want to push, we want to say, okay, this one's going to the end of the list, the bottom of the list. We push another value into our array and it adds it to the end. Length is now 3, so it will say Sam, Vasil, Mimi. If we use names square brackets 2, that is the 3rd element in the array, or the element at index 2, sorry. That will give us back Mimi, which we've just added to the end of the array. So it starts off with 2, we add something in, it now has 3. That is known as mutating the array. So that's something that will come up later down the line. And depending on who you talk to, it's actually bad practice. Mutating anything is generally isn't something that you want to do, but for these sort of early steps to getting used to arrays and objects, it's what we're going to be doing. So we mutate the array, so we just push it in and it adds it to the end. But we're using const. I thought that constant meant something didn't change. Can anyone remember the sort of phrase I used to define the behavior of a constant variable that is more accurate? You think in your head constant means something doesn't change. Now that's not strictly true. Can anyone remember the phrase that is true?
I think what you said, it will be constant, but it can be reassigned.
It will be I think, did you say can't be reassigned or can be reassigned?
It can be reassigned, but it can't be changed.
Okay, the opposite. So you're on the right line. So that's a good answer. I think people don't like it when I say, oh, actually, that's the exact opposite of what you just said. But actually, that means it's a good answer because you're kind of thinking the right way. You just got something switched around the wrong way. So if ever you answer a question and I say, well, actually, it's the exact opposite of what you just said, don't feel bad. That's actually a good thing.
Okay.
So, what did you say? You say it can't be changed, but it can be reassigned. So it's the opposite. It can kind of be changed, but it can't be reassigned. So this array is always going to be accessible at this names variable. But here we're calling this function on the array. So we're changing the array, but names, we cannot then say names equals a new array or names equals just a sentence that describes them. We can't say names equals, but we can call things, we can mutate the array. We can call functions, we can do stuff with the value, and it's not only arrays, strings can do this as well, numbers not so much. But generally, if you have an array that's stored at a constant variable, you can change it as much as you like. You just can't reassign it to a new array or value or anything. Okay, now we want to remove elements from the array. We have two names again, names length 2. We call a function names.shift. It removes the first element from the array. So now this names is still going to point to this array. It's just not going to have Sam in it. So it's going to have length 1, and only Vasil is going to be in the list. The sort of opposite, not really opposite, but the other option here, pop, we remove the last element from the array. So in that case, we just had Vasil. If we call pop, it actually would kind of do the same thing as shift, because there's only one element in the array. So shift takes the first one, which is Vasil. Pop takes the last one, which is Vasil. But pop removes the last element from the array. Now, does anyone know what shift and pop return? So functions like this kind of do something, so they mutate the original array, and they often return something back to you. Does anyone know what they might return, or just have a guess?
The return an array.
It would return an array. So what would be inside that array? So if shift removes the first element from the array and it's returning an array back to you, what would be included? Would it be Sam, or would it be Vasil, or would it be something else?
I guess the one which is being shifted, like the same.
Okay. Good. You're almost there. That's kind of what you. So you're thinking it's probably going to include the thing that's been removed. Good, because you've just kind of removed that. You kind of maybe want to do something with that. But there's only one. Shift only ever removes the first element. So when you're doing something with one thing, one element, one value, there's no point storing that in an array. You can, but there's no point. So you're half right. Shift gives you just the element that was removed. So not an array that contains the first element, it just gives you the first element. So that is something you probably do fairly often want to use. I want to update the array, remove that, and then display whatever was removed. The same with pop. It will return the element that was removed to you, but because it's only one, it doesn't return an array of them, it just returns that one element.
I see. If it's more than one element, it'll return an array. It'll give you an array then.
Yes, exactly. And so on this slide here, we do have some examples of functions which do things with more than one element, and therefore they do give you arrays of those elements back. So here we have a slightly longer version of our names array. We can find out the index of a value. Now, in this example, it's a bit silly because we've just hard-coded everything, and then we're hard-coding this, and we can kind of just see that Vasil is at index 1. But maybe, I don't know, we randomize the order of this names array, and then we want to find the position that Vasil is in, and we can call index of. So we want to find out the index of a value. So we pass a value and it kind of runs through all of the elements in the array until it finds one that matches, and it returns the index of that element. Splice, in this case, we're passing two arguments, we're passing 1 and 2. Here it's going to remove two elements starting at index 1. So where shift removes the first element, if you want to remove the first two elements, we could pass 0, 2. So I want to take the two elements starting at index 0, so it's going to take the 0th element and then the first element, and it's going to give us those in an array. But this is slightly more flexible, so it doesn't always start at the very beginning of the array. Here we could remove the 157th element, and from that position we remove 64 elements. So this is much more flexible than using shift or pop or whatever. We can take a sort of splice, hence the name, we take out portions of the array. Now, slice doesn't actually remove it, doesn't actually mutate the original array, whereas splice actually is taking elements out, and actually you can use it to replace elements with some new value. Slice, it doesn't change the new array, it just gives us a copy, it gives us a portion of the array. So it is the starting index and then the exclusive ending index, I think. So I think we would get just Facile. We'd get an array that contains just Facile. We might get Facile and Mimi, can't quite remember. Splice and slice, they're, of all of the rest of the sort of array methods, array functions, they're probably the two most common of all the others. So push and pop and shift and unshift, which we'll look at when we're practicing. Those four, probably the most common. And then splice and slice, significantly less common than those, but they're probably like the next most common. But they're so, I at least use them so infrequently, I always have to look up the MDN documentation about what the order is. Because, for example, splice and slice, well, firstly, they're quite similar names, and this one removes two elements starting at index 1, but I'm pretty sure slice returns elements starting at index 1 and ending at index 2. So actually, they do two different things, which I don't like. I think that's stupid. But I always have to look that up. We'll read some stuff on the MDN documentation in a second. Yes, I got through, I think, 2 slides without yawning there, and now we can actually write some code. And now I'm just going to do the opposite, aren't I? I've said that I'm not going to yawn now, but I'm just going to actually end up yawning all the time. All right, so does anyone got any idea of, I think for now, for keeping things simple, we're not having objects in our arrays. I think we just have like names of stuff. We have names of towns, let's have stations. What's everyone's nearest station? Can be tube, can be train. I'm currently on the Kent coast at the moment, so my nearest is Whitstable. What's AJ, what's your nearest station?
before I'm typing in before I'm saying.
Romford. That's a shame, isn't it? Yeah, maybe just post them in here rather than like unmuting and stuff. So we're going to have a couple of arrays and usage stats. So how many people use Whitstable Station in a year? Let's say, I don't know, 1.2 million. Let's go big with the numbers. Anyone else want to post? Or is this like a breach of GDPR? No one wants to share. No one wants to share where they live. Earlsfield. Good. Earlsfield. Okay, so Romford. Romford's probably more than Whitstable. I'd 2.2, just around 2. Earlsfield. Is that Southwest London? I mean, I don't really know. But probably higher if it's closer into London.
Yeah, it's southwest.
Southwest, yeah, near, sort of further down from like Clapham. I think. Is it? Yeah. Okay. East Tilbury. I think again that's sort of in London, but it sounds like a tiny little village somewhere. So we're going to go really low. 0.
It's definitely not in London.
Is it not? Where is it?
Nah, they might count it as London, but it shouldn't be.
Okay, yeah. But is it a national rail station or a tube station?
National Rail for sure.
Okay, so yeah, I mean it sounds lovely. Angel, that's going to be high, isn't it? 4. I bet these figures are way off. Barking. Oh, this little thing is annoying. Okay. So, I made up 6. Okay, so we have 2 arrays. We have a bunch of strings and a bunch of numbers. If we want to, let's first log them out, see what they look like. So stations. Remember in the first lesson when I said console log is your friend, you may or may not have realized at this point that you can just pass any number of arguments through to it. I think people initially don't quite realize that, and so quite often I will sort of pass almost like a key value pair, which when we talk about objects you'll understand what that means, but like a label and a value. So let's run node arrays. So we have the array that's denoted by the square brackets, but then remember our sort of primitive data types, strings and numbers and booleans and stuff, they actually display differently in our terminal, because the terminal knows, okay, you're displaying a string, you're displaying a number. So inside the array, it adheres to those rules. So we have our stations here and our usage stats here. Okay, so I want to sort of take out our first station. I don't know what it is. Let's pretend that this is sort of a user generated. I mean, it was a user generated list of stations or of values. So if we take out the first station that was added, we can call stations.shift, and we'll see what that first station is. Oh, I'm going to show you another trick. Do I have it installed on here? I think I probably do. Nodemon or Nodemon, or I don't know how to pronounce it, but arrays.js. So Nodemon, yeah, I don't know how to pronounce it really. Rather than calling node every single time, it will watch changes to your file And when you save the file, it just runs it again. There you go, starting node arrays.js. But if I make a bunch of edits, if I hit save, it just runs it down here automatically, which when you're playing around, when you're doing stuff like this, it's a real help. But we have our first station, and that is Whitstable. Now, if we look at stations again, we see it doesn't have Whitstable in it. We have mutated that array. We removed it from the original array, and we have captured it because Shift returns that value. Quite often I see people do something like this. This sort of achieves the same thing. So we see here first station Whitstable, and stations again no longer has Whitstable in it. And it's kind of nice and readable and clear. So first station is stations 0. So we use the index accessor 0 to get the value at the start of the array. Then on the next line, we remove that first element from the array. But that's quite nice. Yeah, like I say, it's readable, but I think if you're doing that, it would be nice if it's a conscious decision, and you're deciding to go for readability rather than sort of simplicity, where you can combine those two actions into one line because Shift returns the element. So let's do the same with last station. Stations.pop, last station, and we have last station barking. Stations again no longer has barking. Okay, that's all good. That's pretty straightforward. Now let's look for, let's do index of. So index of Whitstable. Let's do stations.index of Whitstable. We need to log it out. Console log index of Whitstable. We have -1. Why might we be getting -1 for the index of Whitstable? Does anyone know?
Because it was just removed?
Exactly, because it's no longer actually in there. It's a bit weird. I mean, now I think it makes sense, but when I was sort of first learning and occasionally used index of, because you don't use it that often, but I always would kind of get annoyed why it's -1. Why couldn't it just be like false or something to say no, it's not in there? But that kind of makes it confusing with a 0. So it gives you -1 if the element that you just looked for is no longer in the array. Now, we can pass a reference to a value. That's the whole point of using these variables. So index of Whitstable, index of first station. It's going to give us the same thing. Index of Whitstable is not defined, I see. Index of first station, it still gives us -1 because when we created that first station, we are calling shift. But if we don't call shift and we leave it in there, so we just access the first station, then we get that is a call that I will not answer. Okay, then we get the first station we get index of 0 in the array because we've kept it in there. If we do this more readable thing, we're still getting -1 because we're taking it out, because we're shifting it out from our array. Okay, now let's do something with the numbers. So we have, let's do Earl's field. Say index of Earl's field is stations.index of the value Earl's field. Let's make sure that that works. That is giving us 1. Is that correct? 0, 1, 2. But then there's all sorts of stuff happening when we're shifting and popping and stuff. So we can't really be sure at this point what index Earl's field actually is. So we've got index of Earl's field. Then we can go to stats. What should I call it? Usage stats. Console log Earl's field is used. Usage stats. Then we access the index using that index of Earl's field in the other array, million times per year. Earl's field is used 2 million times per year. Is that correct? No. We don't know, but we've said that Earl's field is used 2.3 million times per year. Because we are storing our data in sort of 2 separate but really quite closely related arrays, as soon as we change anything about our first array, our second array is now kind of out of whack. So if you are mutating your arrays and if you are storing your data in any way like this, then you have to make sure that both arrays are kept in sync. Now, when we talk about objects, you'll see that this is not a great way to be storing all of this data. Objects are going to give us a much better way. But there's the odd occasion where you'll be dealing with sort of multiple arrays and you want to get something that is at the same index of all of those arrays. Okay, let's do some array of arrays. Did we do usage stats? I suppose we didn't do too much there. Okay, let's do something else. So I don't want to mutate any of this. So let's do station. I don't want to pop. How can we get the last station without using pop? So I don't want to use pop, but I do want to access that last station. What can I do?
You can do length -1.
Yeah, exactly. So stations.length is going to give us the number of elements in the array. But remember, length isn't 0 index, whereas our indexes are. Therefore, to get the 5th element in the array, we actually need to use 4. And if there are 5 elements in the array, that's the last one. So length -1 we use as the index to get the last station. Okay, index of first station 0, good. 2, Earl's field is used 2.3 million times per year. Okay. Now, let's call usage stats dot sort, and then console log usage stats. So sort now, next week possibly you're going to learn how to use sort in more detail. But if we have an array of numbers, actually probably an array of strings as well, but it'll do something funky with strings. But if we've got an array of numbers, we can just call the function sort. JavaScript knows that you probably want to sort it in ascending order, so it starts at the lowest, ends at the highest. So also be aware that this will mutate the array. So we've just called the function sort. It doesn't return a new sorted array, it just changes the order of the original array. So again, we've now messed up the order of the stats versus the names of the stations. So we don't really want to do that. Now else field is used 2.3 million times per year. I did think of something else that we can do. We get the index of that, and then the yeah, okay. Let's write a function. Function usage stat. We're going to take station name, and we want to return the usage stat for it. So this little sort of set of commands that we did earlier, we're now going to do these inside a function. So index of station, we have our array of stations, index of station name, then we can just return usage stats index of station. So now console log usage stat pass in Whitstable, and we get 1.2. Let's pass in barking, and we get 6. So this is a pretty common. You're going to do something like this. It's just 2 lines, and so you think, oh, what's the point of having a function? But it just makes it really nice and neat when you're calling this like 50 times in your code. That's gone from 100 lines to 50 lines. The number of lines is not a great metric, but again, it's readable. This code only exists in one place. So now, if we want to change it to Birking, we get undefined. So now we should probably do some sort of error handling. If we had this 50 times throughout our code, we'd have to deal with this in 50 different places. Now, because we've separated it out into a function, we only have to handle this once. So if index of station is -1, we can return false or a string that station is not in our database. That station is not in our database. That logs out because we just log out whatever we get here. So that's much nicer for our users. Okay, so we've sorted. We can. What could we do? We could have a sorted. Oh, that could be fun. We can sort the names array based on the new order of the sorted usage stats array. Okay, so first we want to sort the usage stats array. I think a couple of weeks ago, I think someone mentioned pseudocode, and I think I said something like pseudocode is sort of a waste of time. The closest you should be getting to pseudocode is sentences that describe what you're doing. And this is what I'm going to do here. So we want to have a few steps to get to our end goal. And so we're just going to write them down. I just need to think about all of those steps, and then I can write the code to achieve each one of those steps. This really helps me. This is what I do for my colleagues. I'll create a sort of ticket for them to work on to build a new feature, and I will think about the things that they should do in which order, and I'll write a little sort of checklist for them to work through it. So it's really helpful. Okay, so we want to sort the usage stats array, but we first want to keep a version of the usage stats array that is in the original order, so we can access the values when we access the name in the station array that is in the same order as the usage stats array. So before we sort the usage stats array, make a copy of the stats array to keep the order, and then we sort the usage stats, or we could sort the copy or whatever, but we keep that order around, then we sort it, then so in this function, what's the function called? We're going to take the name of a station and we're going to return the position in the sort of usage stat table. So we're going to station usage position, table position. So we're going to take the station name, and inside here is where we do these things. So we want to make a copy of the stats array, we want to sort that stats array, we want to find the index of station name in stations, find the usage stat using index in original stat order, and then we find the index of stat in ordered stats, return the value at that index. So you don't have to even think about kind of what you need to do. It's sort of how you do it. So now at this point you can just Google every step to figure out how do I make a copy of an array, how do I sort an array, how do I find the index of something in an array. These are all just like one-liners. I think they'll just all be one-liners that you can easily Google. But because you have broken it down into steps that make sense, it just makes your life so much easier. Okay, so copy of stats is going to be usage stats. Now we're going to sort of discover a nice or a different way to make a copy of an array a bit later on in the course. But what we can use is slice with no arguments. So slice returns a section of the array, but actually both of the arguments are optional. And so sort of weirdly, if you don't pass any arguments, it just takes everything, which it kind of is confusing. There's a slightly different way of making a copy of an array that we'll talk about in a few weeks. But for now, it's pretty interesting to know that slice with no arguments just returns a copy of the array. So now I've got copy of stats, and let's sort our copy. So copy of stats.sort. We don't want to go outside of this function and change that usage stats array, because there's all sorts of other stuff that's using that data. So inside here we make a copy and we change the array in here. Next, we find the index of station name in stations. So station index is stations.index of station name. We know how to do that. Now we find the usage stat index in original stat order. What? Find the usage stat. Oh, using index. I'm confused. Find the usage stat. Oh yeah, okay. So find the usage stat. So usage stat for station is now the original usage stats array at that station index. So because they're all in the same order, we can find out the position of the station, then access the value in the usage stats array. Then we find the index of it in the sorted array. Usage index in sorted is copy of stats.index of usage stat for station. This is confusing. Then we return the value at that index. So we return the what do we do? Station usage table position. Okay, so actually we're just returning that, aren't we? Returning that plus 1. If we take the 0th element, it's going to say 0, but station usage table position, actually we want that to be 1. We want that to be kind of user friendly. So let's say station usage table position barking. Now I think I'm sorting it the wrong way, so we're going to get 6. Is that correct? Station usage. Oh yeah, okay, yeah, 6. So I was kind of hoping it would be 1, but it's 6 because I'm sorting the wrong way. Let's do East Tilbury. And that is actually number 1. Oh, I see, yeah. So it's, again, it's messing with my head. So how can we do that? Usage index in sorted. So that gives us 5. So minus usage stats dot length. No, that's not going to work. Whatever, I can't be bothered to do maths. Can we reverse an array? Reverse, yes we can. But that doesn't mutate it. Oh, it does mutate it. Great, it has worked. Okay, so all of these logs, it just is too confusing. Okay, so station usage table position for barking, because that has the highest number of users here at the end. That is number 1. And East Tilbury, that has the lowest number, so it has number 6. We could stations 0 do something like this. 4, 5, and actually that ends up in 5, 4, 3, 6, 2, 1. So we can do something like this. This is not nice code. Okay, in 5th place is Whitstable, in 4th place is Romford, 3rd place is Earlsfield, 6th place is East Tilbury, 2nd place is Angel, 1st place is Barking. Now, if we have time later on, I suppose we should refactor this to display it in like table order and usage order. So it would be nice if we could sort of print out a kind of league table of stations. So it says 1 Barking, 2 Angel, 3 Earlsfield, and so on. But we'll come around to that at the end after objects, and if we do have time, I think that might be a nice little exercise. But arrays are incredibly important. You're going to be using them so much. And really what we've just done there is sort of interesting. You're sort of dealing with 2 arrays and doing a few things here and there, but really that is absolutely the tip of the iceberg. There's so much more, and I very rarely these days use any of the functions that we just sort of talked about. So push, pop, slice, splice, sort. Yeah, I'll use sort now and then, but most of these I don't actually write the sort of code and code bases and style that you will end up writing. You kind of use arrays in a completely different way. So this is just the start. They're really incredibly powerful. So any questions on arrays? There's also a joke that I can't quite remember how to phrase it. It's something like, why didn't the programmer have a promotion? Because he didn't get a raise. Because it's something like that. It's a really terrible joke. It's a bad one. Okay, Mushtaq says array 10 equals undefined. Would this also output true? Yes, because undefined. So undefined is falsy. I think last week, 2 weeks ago, we looked at comparisons and conditionals. And sorry, let me. And remember that the 2 equals versus 3 equals thing. 2 equals is type coercion. It's trying to make it true, and so array 10, which doesn't exist, which is undefined, equals undefined. That makes sense. You kind of expect that to always be true, but actually undefined, somewhere in sort of your computer there is a bit of data that is the one place that undefined exists. So you're right, 2 equals and 3 equals, like strict equality, it would equal to true, because the thing that is stored at position 10 is the value undefined, which is kind of messed up because undefined actually is value. It's just like the lack of a value. But yes, you're right. Any more questions? Okay. Now objects. Oh, I didn't change the font on. Oh, maybe I stopped at arrays. Anyway, objects are pretty similar to arrays. Actually, they're identical. So arrays are objects. Now I think there's some slides at the very end that says like, aha, arrays are actually objects. But the way you use them is completely different. It's almost incidental. It doesn't really matter that arrays are technically objects in JavaScript, because you do use them in very different ways. But ultimately they're just collections which are not ordered, whereas an array is a collection which is ordered. Objects are collections which are not ordered. And the values that we store inside our collection are accessed using keys. Now in an array, our keys are indexes. In an object, a key is a string. And therefore, we can be much more descriptive with what the value being stored at this position is. It's not the first position, it's the position that represents a name or an age or a usage stat or something like that. So an object stores a value at one of these keys, and this is a key value pair. So key value storage, a key value pair is one key that's a string and one value that's anything. And key value storage you'll see all over the place. Objects use curly brackets and square brackets. The vast majority of the time it's just curly brackets, and you use dot notation to access properties, to access keys on an object. But you can also use square brackets, which kind of, again, leads you down the line of realizing that objects and arrays are actually the same thing. So I'm creating, oh yeah, I did this. I changed the font here. I must have just missed that slide. I don't think anyone else cares, to be honest. So here we're creating an object. This is actually a sort of, as far as objects go, a kind of reasonably complicated one, and it's because of this favorite foods property, but we'll get to that in a bit. So we've got our curly brackets that's denoting the start and the end of this object. Everything's comma separated, so again it's kind of like a list of values. In at the first line, now that's not necessarily the first key value pair, because objects don't have an order. You cannot guarantee the order. This is just the first one that I wrote, or whoever's written this has written name Jasper first. That doesn't mean it's the first value inside our object. You cannot guarantee the order of key value pairs in objects. But we have a key of name and the value of the string Jasper. We have a key of age and the value of the number 2, a key of breed, the value of the string exotic short hair. And here we have one that's slightly more interesting. We have a key of favorite foods, which is a value of an array, which, as we just discovered, an array is actually an object. So now we have an object within an object. You can have any value assigned to a key in an object. Okay, so we're going to keep that object in the top left corner so we can keep referring to it. Cat dot name, so this is dot notation. We access properties on a object, or we access values on an object using a key, and if possible if JavaScript allows, we can just use dot notation to access the value at that key. So cat.name is equal to Jasper, cat.age is equal to 2. Now here, cat square brackets string age is equal to 2. Now this looks like an array, sort of, but we're using a string instead of an index, instead of a number. So all the keys are actually strings, even though in JavaScript we don't need quotes around the keys. They are actually turned into strings. So we can pass a string into square brackets, and that will allow us to kind of dynamically access a key on an object. This age, I mean, writing it like this is stupid. You would never really do this. But if age was actually a variable called key, and we don't know what that key was, maybe the user chose between name, age, and breed, and that selected key is then going to be used in place of this string to get the value that the user just requested. That's when you would use square brackets. There is another time when you'd use square brackets, and we'll see that later. Type of, remember, that gives us the type of, hence the name, a value, and we can access breed. Again, cat breed is string. Type of the value stored at this key is a string. Now, as well as just accessing object properties, we can set additional object properties. Because a constant variable cannot be reassigned, but it can actually change, this would still work. So we've got our constant variable of cat, but we're not changing the value of that variable, we're just changing the value of what's inside the collection that is that variable. It's a bit confusing, but we can change it. So cat.color equals gray, so we set it to the value gray. Cat BFF or cat.bff is set to Archibald, which I think is the name of Vasile's dog. Okay, more object properties. Cat favorite foods is an array. We saw that by the square brackets and the comma separated values. Therefore, we can call our push function on cat.favoriteFoods. It works. We can push in salmon to the end of the array. Now cat.favoriteFoods has a length of 3 because there are 3 elements in there. Cat.age, similarly, that's a number, so we can call ++ on the number and it's going to add 1 to the number. So age is now going to be 3, favorite foods is now going to be sardines, tuna and salmon. We can access properties on the object as if they are variables that are stored in any other way. Okay. Now we're going to, unless anyone has any other ideas, we're essentially going to rewrite all of that stuff that we just wrote or in here in objects. So now we're going to still have an array of stations, but each element in this array is going to be an object. So let's copy these for the values. So we're going to take all of these, put them in here. We want to open the curly brackets and say name. We want to, it's not going to work nicely with all of them, but yeah, whatever. Then we want to close it. Okay, I'm going to format as well. So it splits it onto multiple lines. So all of our stations now have a name of some string. That's basically the same as this array. That doesn't really give us too much. But now what we can do is usage. We can say usage 1.2 to 2.3, 0.3, 4, and 6. Now we don't have to worry about if we remove the third element in the array, we also have to remove the third element in the other array, and we don't have to say, okay, what's the position of this, and then get the position in the other one, and then now the name and the usage stat, they're just linked. They're forever contained within one object. So each object is going to represent a station. Now let's first station is stations 0. Let's have a look at it. Okay, we have that Whitstable station with the usage stat printed out pretty nicely in our console. Nicely for a coder. That's not very user friendly. So what we could do is have a string name first station dot name and used by first station dot usage, chuck an M at the end, so name Whitstable used by 1.2 million. So we've used dot notation to access the name values at this station and then the usage value at this second station. Now we can function use a station. So use station is going to take, it's going to be a bit complicated actually, fire, because the index of. So because I don't want to go into a bunch of other stuff, we're going to pass the index of a station, which is a bit weird, but never mind. So we are going to access stations index dot usage plus plus. We're just going to increase it. That's a million people using it. Then we can return this again. Actually, we could get the station into a variable inside the function, and we could have stations index here, here, and here. But as soon as you have it more than once, maybe twice is fine. But as soon as you have it more than twice, you just want to make it easier to read for you when you're coming back to it. So just store that in a variable and then use it your 3 times. So console log use a station 0, use a station 4. So there, Whitstable has now been used by 2.2 million people, and Angel has been used by 5 million people. Now we want to let's have I'm trying to think of a key that we can add to these objects that might have a space in it, or it might have a hyphen in it or something. I don't really think there's much we can do, but let's do something like add custom stat. So we're going to take a key and we're going to take a value. Now also station. So station index. So we get our station by accessing station's station index. We then say station key equals value. So remember, with our square brackets, we can set keys on an object, and by using this key argument, it's now dynamic. It can be anything. Whatever gets passed in to this add custom stat function, we're going to use that as a key. It's always a string. Let's look at what happens when we pass something other than a string, but it is always a string, and it's going to be set to whatever value we want. So let's return that station after it's been updated. So console log add custom stat to Whitstable. The string of best fish and chips is VC Jones. Honestly, they are the best. They cook them in beef dripping. So those of you who, I don't know, vegetarians or whatever, you don't really want to go there, but I think you should, because it's worth it. It's really excellent. So we passed this very nice and descriptive string as a key. You can see in our console that it has displayed it slightly differently. So technically, all of those keys are actually strings. But if they are strings without any sort of special characters like spaces or hyphens or whatever, then it can be interpreted and displayed almost like a variable. But if it's got spaces in it, we can't write station dot best space fish and chips. That doesn't work in JavaScript, and that's pretty much the reason why, if we have any special characters, we always need to use this square bracket notation. So we have square brackets around here, and that would now work. So console log station best fish and chips. We try to run it with this still there, it just doesn't work. Station.best, and then it tries to do something, tries to access a variable called fish, and that just doesn't exist. There isn't anything called fish. So that's why if a key has special characters in it, oh yeah, we have stations, so stations 0, best fish and chips. That now gives us VC Jones. If we access best fish and chips on stations 1, gives us undefined. So just like our array where we accessed index 10, it's exactly the same. We're accessing index 10, which is actually the key 10, but it doesn't exist. It doesn't have that key, so the value is undefined. So it's just the same here. Station number 1 doesn't have a key value pair of best fish and chips and anything in the value, therefore it gives us undefined. Okay. So what else did we do with objects? We added keys. We can delete a key as well. So function delete key, so station index key, let's get the station at station index. This again is something that you don't do very often at all, but very occasionally you might want to do it. There is a keyword of delete, so we can say delete station index key, delete the value stored at that key, and it removes the key. So we then return station, and we can call delete key, best fish and chips, and we get the same object with best fish and chips there. Now, as I was writing this, I did think, for some reason in my head, I thought, actually, you know what? I'm not sure if it works with dynamic keys like this. So, just for sanity, let's delete name. Oh, delete station index. Oh, station index. There we go. Station. Okay, so I still will admit that I did think, oh, maybe it won't work with a dynamic key, but it does work with a dynamic key. Okay, so we have removed that key from our object. Like I said, it's not very often that you use delete to delete a key, but I've used it a handful of times. Okay, so we've got a bunch of objects in our array. I said we'd see what happens if we try to add a custom stat or add a key with something that isn't an array. So let's add a custom stat to 3, 0, 1, 2, 3 East Tilbury. Let's say is in London false, because Daniel said it sort of isn't in London. So look at what it's done here. Name is Tilbury, usage 0.3, object, VC Jones. That's weird, false. I don't know what would go on there, but the important thing is that we are using an object as a key on another object. So this, I can't remember if I spoke about this a couple of weeks ago, but you will see this a lot. When JavaScript needs to use a string, but you pass it something that isn't a string, it tries its best to convert it from whatever it is into a string. Most types have a function, in fact, possibly all types have a function called toString. So let's see what that does. Console log true.toString 5.toString some object hello yes .toString. We get the string true. Let's look at it differently. So we get the sort of Boolean version and then the string version. You can tell that they're different just by the colors. We get the number version and then the string version. And then here we get the object and its sort of best attempt at the representation of that object in a string. And it always, regardless of what's in the object, so let's remove hello yes, and it's just an empty object, it still gives us object. As soon as it's an object.toString just gives us a string that contains square bracket, lowercase object, uppercase object. What do we get if we have an array? An array of names. Ha. I actually wasn't expecting that. I was expecting to see object. So where an array is just an object, it's an object that has some other things on top of it, like push and pop and all of those things. It also has a different implementation of toString. So an array knows, okay, even though I'm an object, I actually am going to sort of do my best to convert my contents to an array. So actually that sort of makes sense, even though an array is actually an object. So if you try to use anything other than a string as a key, it is going to try to convert it into a string. Having said that, I think I'm forgetting numbers. So okay, no, it does, yeah. It does convert it to a string. So on this one, I've just added the key of 5 with the value of false. And this is pretty much just what an array looks like under the hood. An array is simply names is, let's do Sam Vasile. Fake array is 0 Sam 1 Vasile, and length is 2. Fake array 0 gives us Sam. Fake array dot length gives us 2. So that sort of looks like an array, and that's because an array is just an object where all of the keys are numbers. They're all indexes. Okay, 34. Now, I think that's kind of everything we can cover on sort of just the few different things you can do with objects. After this, I said we'd refactor. I've forgotten what I said we'd refactor, but we will do that. We'll do something. For now, any questions on objects? Let's see if anyone's posted anything. No. I think, as I said during the first lesson, feel free to post stuff in here as and when you think of them, and then I'll come and answer them later on. Maybe you have no questions. Okay. Can anyone remember what I said I would refactor? So something in arrays. Oh yeah, we display the table. Okay. So we're going to write a function, display. I might do it in a I don't know, league.js. So we'll take these and we'll run league.js. Okay. Display table. So when we're writing this function, what we could do is just this. We'd have no arguments. We just have display table, and it kind of goes outside to the global variables, stations, and usage stats. But a better way might be, because we've got stations and usage stats, and then we've got teams and points, and then we've got I don't know, hospitals and COVID patients, and we now have a bunch of different sets of data that we can call display table. We want to be able to call display table using this array as the sort of names of things, as the sort of labels, and this array, usage stats, as the sort of don't know, sortable. Don't know what a nice name for it is really, but we want to call the function multiple times, passing in different arguments: stations, usage stats, teams, points, hospitals, COVID patients. Yes, they're all the same values, but whatever. So we're going to have labels and values. Yeah, that sort of makes sense-ish. It's sort of generic enough. That'll do. Okay. So how are we going to do this? Let's write our instructions. So I think again we want to copy values array, sort copy of values. Then we iterate, and this is going to be a sort of introduction to Thursday's lesson. I think. No, actually, maybe we'll just assume that there's always 6. It's a bit weird, but I don't want to get into iteration because that's Thursday. That Thursday's for loops, and this is perfect for a loop. But let's just always pretend that there's 6 elements in the array. So we sort the copy of the values, and then for each of those elements, we find the position in the original for each element find position in original. For each value, find index in original array. Then we get the name, from, or get label from labels array using value index, then display label plus value index in sorted array. Maybe. Okay. So we have our copied values, and we use slice with no arguments. I think on the MDN documentation it actually says, let's look at array.slice. I think it specifically says somewhere using slice script write array like objects. Okay, maybe not. I thought because it's like relatively common to use slice as a copy. I thought that it specifically has a section about using sliced to copy, but we're copying the array. Therefore, not COVID patients, copy values. We can just call sort without worrying about changing our original values array. For each value, we want to find the index in the original array, get the label from the labels array using the value index, okay, and then display label and value index in sorted array. So I think for this we want another function. So display row, and we're going to have labels, values, find index in original array, value. Okay, so I want to take all of these, put it in there, and I want to call display row with the labels, the values, and the copied values, the sorted copied values of 0, 1, 2, 3, 4, 5. This is where on Thursday we'll replace this with a loop that does it, because what if we pass in an array that has 10 in there? What if we have an array that only has 2? But for now, we're just going to copy this 5 times. So for each value, find index in original array. So we're passing values. This is the original values array. Therefore, value index is values dot index of value. We get the label from the labels array using the value index. Label is labels value index. Display label and value index in sorted array. So actually, kind of need to sort again. Sorted values, sorted values. Let's pass it through. Okay. Now, didn't really want to save that. Sorted values not defined. Oh, I've got copied values. Copied values. Now, in sorted values, we want to return, although let's just log it out, console log, a string where we have sorted values dot index of the value that we are currently looking at, then the label. +1. There we go. East, Tilbury, Whitstable, Romford, Earlsfield, Angel, Barking. Why is it doing it so many times? Oh yeah, because of that. So if we did have different values, okay, whatever, let's do different values. Teams, Spurs with, yeah, not a huge amount of points. I'm just going to change these Man U, Man City, Chelsea, Accrington, Stanley, and Barking. That can be a team. Hospitals, Queen Mary, that's probably a hospital. The Nightingale, that's got loads of COVID patients. Earlsfield can also be a hospital, East Tilbury, etc. So now we have the same function that's called 3 times with 3 different sets of data. East Tilbury to Barking. We're sorting it the wrong way. Therefore, we can call reverse and there we go. We have Barking at the top, Angel, Ersfield, Romford, Whitstable. If we want to show the value, then we can. Okay. Cool. Now, if we had a slightly better way of sorting, all of this would be so much easier using objects. Now, I didn't want to get into the sort of better way of sorting because it introduces a whole bunch of other concepts. But this sort function can be manipulated and used in all sorts of ways. We can sort it exactly how we want. At the moment, we're giving it an array of numbers, so it kind of knows how to sort it. But if we had this array of objects, we can pretty easily just sort it based on this usage property of each object in the array. So in a few weeks, because like I said, there's other concepts like callbacks and stuff, and that's too complicated and confusing and just to get a sort done. I'm not going to go into it, but all of this, doing it like this actually is quite a nice challenge. It is going back and kind of limiting yourself to not using the useful ways to do everything is actually really good practice. So I found that quite enjoyable, really. So 48. Does anyone have any questions on arrays and objects, or anything you want me to cover again, or any suggestions of things we can do with the data we've got? Okay, Mushtaq says, maybe later. Feel free to reach out on Slack and I can give you a hand. As usual, I'll be deploying